Assalamu alaikum. In this video I will be explaining this article 6.3 from the book of Design of Machinery, the instant centers of velocity. This method is basically used to determine the absolute velocities of different points on various links in a mechanism. This method we can say that is the commercial method, and with this method we can fastly determine the absolute velocities of various points in a mechanism. So at this stage we must also know what is the difference between absolute velocities and relative velocities. So as the nomenclature indicates, that absolute means that velocity is calculated with respect to some fixed frame of reference, or with respect to some point, or with respect to some link which itself is stationary or is not moving. So if a velocity is calculated with respect to some origin or point or any body which itself is stationary or not moving, then that velocity will be called to be absolute. But if some velocity is calculated with respect to some moving frame of reference or moving coordinate system or moving point or moving link, then that velocity will be termed as to be the relative velocities. So this method is actually used to determine the absolute velocities of various points in a mechanism. But if we are required to determine the relative velocities, so how they will be determined? So the method is that once the absolute velocities have been calculated using instant centers technique, then we will be writing the relative velocity equation conventionally. Using the relative velocity equation, then the data or magnitudes and orientations of the absolute velocities found from this instant center technique will be input in that equation, and from that equation the magnitudes and directions of the relative velocities will be found out. So that means directly this method can't be used to determine the relative velocities, but this method, once it has been applied in a mechanism and instant centers have been found out, then this method is able to fastly determine the absolute velocities. So here it states the definition that instant center of a velocity is a point common to two bodies in plane motion, which point has the same instant velocity in each body. So the definition is quite simple, that instant center of velocity is a point that is common to two bodies. Means there may be two bodies which have different motions in a plane, but practically that point is common to two bodies and it has the same velocity in both bodies. So that means that point means the instant center may not be physically located on those bodies. So that point means the instant center can be anywhere in the plane of the bodies, or in the plane in which the both the bodies are located. That point can be located anywhere in that plane. So this method is actually is called the instant center technique, and that is common to two bodies in plane motion, and it has the same instantaneous velocity in each body. That means in the next moment that instantaneous center will be changed for both the bodies, and in this way, so its further explanation will be made as we further proceed in the article. So here it also states that instant centers are sometimes also called the centros or poles. So it says that since it takes two bodies or links to create an instant center, we can easily predict the quantity of instant centers to expect from any collection of links. So the combination formula for n things taken r at a time is written here, and for our case r is equal to 2. The formula simplifies to c is equal to n into n minus 1 divided by 2. So in this way, here another principle that has been mentioned here, that is Kennedy's rule, that any three bodies in a plane motion will have exactly three instant centers and they will lie on the same straight line. So this rule will also be explained with the help of example that I will be explaining a bit later. So I will directly be applying this method of instant center on example 6-8. Uh, 6-7 here. Velocity analysis of a 4-bar linkage with the vector loop method. So this example have been solved many times using various techniques, and basically this is the example is actually the graphical position analysis or analytical position analysis in chapter number 4. So I will be explaining the method with the help of this example because the data is available. So the statement is clear that the length of the links are L1 means the ground link as one subscript always denotes the ground link is 100 millimeter. L2 means the input link or crank A spiral length 40 millimeter. L3B connecting rod which is in complex motion always, its spiral length is B 120 millimeter, and L4 is actually the output or the rocker link, its dimension is 80 millimeter, and theta 2 means the input angle for the crank is 40 degrees, and furthermore angular velocity omega 2 25 radian per second, that means counterclockwise because it is positive. So that means conventionally this omega 2, if it is positive, that means it is counterclockwise from the positive x-axis. Find the magnitude values of omega 3 and omega 4, VA, VBA and VB. So as it has already been mentioned that VA and VB are absolute velocities, means if there is one subscript that actually denotes the absolute velocities, but if there are two subscripts like this written as BA, so that means the it is actually the relative velocity of the first subscript with respect to this second subscript. So actually both points A and B are in motion, but the required velocity vector will be located at point B, but it will be calculated with respect to point A. So that means the moving origin or moving frame of reference will be attached with point A. So As the moving frame of reference origin will be attached with point A, the velocity calculated of point B will be the relative velocity, and that will be written as VBA. So if the moving frame of reference is attached, for example, with point B, so this velocity will be written as VAB, means the velocity will be of point A with respect to or relative to point B. So the second subscript is always the relative point with respect to which the velocity of the first subscript point is always calculated. So in this way, so to apply this method of instantaneous center technique, we must complete the position analysis before proceeding the application of this article. So from the position analysis, we are familiar from chapter number 4, example 4-1, that to make for the open circuit, theta 3 and theta 4 are given as. So these terms have already been explained. So I have drawn using Microsoft Word the position analysis already, and I have already uploaded a video that how this diagram, position diagram, can be drawn using Microsoft Word. So I will also be putting the link in the description. So the position analysis can be even can be either analytically completed or graphically. So here the values that are written here, these are actually analytical values because they have been calculated up to 3 decimal, because in a graphical calculation there are a limitation of observations, so decimals are unable to be calculated. So these are in complete integer values. As can be seen, I have not written here any decimals, so these are approximate graphical values that have been measured with the help of protractors. So first of all, I will be showing to locate the instantaneous centers of this open circuit. So I will first of all be copying this open circuit, which is shown in red color, means this crank linked to this connecting rod, which is actually link 3, or its scalar length is denoted by small letter B, and this rocker link whose scalar length is denoted by small letter C, and this is denoted by link number 4, and this link number 1, which is denoted by scalar length D, this is called the link number 1, and it is the ground link. So I will be copying this complete circuit into a separate page. So how we will be copying that, we will be, for example, normally clicking this link, and after that we will be pressing Control from keyboard and having it pressed. As we can observe that the cursor has changed its shape and a plus sign is appearing beside this, as we can carefully observe, and then we bring the cursor onto the other link, and then we can simply click at this link. Remember that control button is pressed. So in this way these two links have been picked up, and for example, if we want to include or add the ground link, so we can in a similar manner click here. So this link has also been included, and as much the links we want we can include in this way. So this link, sorry, here this ground link has been also included, and if we want to exclude some link or body, we can once again click on that. So we will be observing that object or link will be excluded from the selection. So here 4 links means crank, connecting rod, rocker and ground have been picked up or selected. So normal selection can only be multiple selection can only be made using pressing the control button. If we do not press the control button while selection, so the link or the part which has already been selected will be deselected. So once all the links have been picked up or selected, after that we will be simply release the control button and we can copy control plus C, and after that we will be moving on to the next page. Moving on to the next page here, and at some suitable location we can paste this complete circuit here. For example, at its center of this page, at anywhere I will be here keep source formatting in this way. So as it can be observed that all the 4 links have been pasted, and after that we will not be clicking on this page, and as we can observe that here all these 4 links are selected at this moment. So we will just be pasting them and we can reposition them by right and left or up and down arrows as we want. So for example, I want this selection to move towards right, so from the keyboard I will be pressing the right arrow. So in this way, as we can observe that this whole linkage is moving. So in this way we can use right arrow, left arrow, up arrow or down arrow from the keyboard like this. So I want to place it near the center so that it is at some approximate correct location. So here I have stopped it. After that, for example, I can simply normally click in this way. So this link has been placed. In a similar manner, we can also show all other angles and that can be placed here. For example, in the second step, for example, I can copy this angle in this manner, then press control button, for example here like this, and like this. So if the selection of these labels is creating problem, then no issue, we can normally turn by turn pick them and we can paste them here, for example, sorry, like this, and then we can place it here. This is theta 3 1, and in this way, for example, this theta 4 we can just copy. The main issue was actually copying these links in a single step, so that has been done. After that, labels can be turn by turn copied and pasted. So we can place it here just to show, and in a similar manner other labels can also be shown here. For example, we can also show theta 2. It has not been shown here, but we can copy any label, for example this label, and we can copy it, and we can, for example, paste it here, and then we can move it here, and we can say, we can just select it and type 2. So this theta 2 is actually, as shown in the problem, this is 40 degrees, as we can observe here that theta 2 is 40 degrees. So just copy these labels and paste at a suitable location. So these reference lines can also be copied in a similar manner. For example, we can in this way copy these reference lines of angles, and we can just copy them, and we can paste them on the next page here. And here they have been actually pasted at random location, because they can't be directly pasted on the exact location. So just use up and down arrows, right arrows, so that they will be moving relative to each other in this way, as it can be observed. So after that, now move the right arrow in this way. So now this angle, move it a bit at suitable location here. So in this way, these angles have been actually shown, so that the orientations are further calculated and they are readily available. So now the method to calculate the instant center technique is that, first of all, we will be creating a line graph, that actually in the book that method has been stated here. I can give it show here the reference just for your ease. Sorry, here here actually on page number 299, the author has used the term that it also shows a linear graph. So the method is that we will be creating a center or some circle, which actually be divided into as number of divisions as there are links in a mechanism. So if in a 4-bar mechanism we know that there are 4 links, so that circle will be distributed equally into 4 parts, into the equal number of segments as there are number of links. So this is called actually the linear graph, and after that simply these points are these points are actually showing the links, mean this is link 1, this is link 2, this is link 3rd, and this is link 4th. So these points are actually showing the links, and these links will be connected with each other. So in this way, so this is the linear graph. You can further study from here. This is on page number 299 and 300. Method is mentioned. So again we will be moving to the solution of example. So in this way, this was the example, and now we will be creating a line graph. For example, we just create a simple circle here just to make you understand. Here we can fill it, and after that we can just divide this circle. So in a very simpler way, just approximation here like this, and again for example we can just copy this line and paste here, and we can use down arrow for example like this. Again for example we can paste, and this is just an approximation. We are to divide this circle into as many number of segments as there are links. We can for example again paste, and again we can just show here like this, up and down arrows in this way. After that we can for example click on insert, and for example draw text box, and here we can name them just like this is link number 1, and we can shape fill, no fill, shape outline, no outline in this way. And after that we can just copy this label 3 more times, and then we can just move them at their proper locations. So a small effort will work easier here. After that we can just labels have been just copied. After that we can orderly change them, that this is link number 2, and this is link number 3rd, and this is link number 4th. In this way the circle has been distributed into equal number of divisions as there are links, because that is a 4-bar mechanism. So 4 distributions or divisions have been made out. So after that, just with the help of simple line, connect these practically available physical links. Again in a similar manner we can just copy and paste this line, and for example we can move it here like this. Again we can either draw the fresh line, or we can just copy paste it here like this, and in this manner. So again we can move it here, and just from these points we can drag it here like this. So this shape doesn't require to be an exact square or some correct shape, so that can be any approximate shape, just to show these physical links and their connections. So in this way line graph has been completed. So this is called the line graph. It actually consists of a circle which is divided into as number of divisions as there are physically links available in the mechanism, and after that these links are connected with each other so that the joints or instance centers are located. So these are 4 instance centers have been mentioned here, and the unknown instance centers, they will be calculated. So remember that in a 4-bar mechanism, as the author has stated in the description of the article, that all pin joints are actually the permanent or fixed or constant centers. So we can observe that, for example, if we can at a moment label these points. This is point O2, and this is the crank ground revolute, and in a similar manner we can, for example, instead of copying this, we can just copy paste this link here, that this is O4, or we can also we can show the scalar length here, means this is link 1, which is actually D. Scalar length is denoted by D, and now we can just copy and paste here at various location, and now change it. This is link 2 and denoted by letter A, and again, for example, paste, and then we can just move it here. This is link number 3, which is in complex motion, always the coupler link. This is denoted by small letter B, and again, for example, copy and paste this link number 4. In this way we can change and just type it here, C. So as link 1, 2, 3 and 4 have been shown here, so again the labels can also be completed. This is actually, for example, this is point A, which is actually the crank moving revolute, and in this way we can again, for example, change it. This is the point B. So any label can be copy pasted here and just changed here like this. Thus move at suitable location. So in this way complete labeling according to the book has been made. And now we can observe that this link 1 and 2 in this manner 1 and 2 have been connected, and after that link number 2 and link number 3 have been connected in a similar as shown in the actual circuit or diagram, and this one manner link 3 and 4 have been connected. And so actually this this is the line graph of this mechanism or circuit. So here as we can observe O2, O4, A and B, these four revolute joints are all in permanent or fixed or constant instance center because they do not actually change. They are actually practically physically available on the mechanism. So that is why they are called permanent or fixed or constant instant centers, because we don't require them to be located by any technique. They are practically physically obvious and they can be readily located in the diagram. So in this way four instant centers have been located because the formula is actually I can write it here, that the number of ICs for 4 bar which will be equal to n into n minus 1 divided by r factorial. So the factorial symbol can simply be added like this, sign of exclamation mark. So in this way n is actually the total number of links. So as it can be observed that total number of links are 4, and that will be 4 minus 1 which will be equal to 3, and that will be divided by r is actually 2 factorial. So this simply comes out to be 4 multiplied by 3 and divided by 2, which is equal to 6. So there are total 6 instant center for the 4 bar revolute jointed mechanism, all which are pin joints. So 4 instant center means O2, A, B and O4 are readily physically available in the mechanism, but there are 6 minus 4 means 2 unknown are still to be determined, are still required to be determined instant centers, which will be determined with the help of this linear graph. So as we can observe that the instant centers that will be calculated with the help for example link number 1 and link number 3 according to the definition of instant centers, that these are two bodies which will have a common center of velocity, means link number 1 and link number 3 which are not physically directly connected with each other. They do not have a common vertex at this moment. because between link number 1 and link number 3 there are link number 2 and link number 4. So these links are not directly attached with each other. Between them, link number 2 and link number 4 are separating them. So in this way, so this method is actually the method of instant centers is used to locate the instant center for these two bodies, which actually the author has defined in the definition. So in this manner, so the method is that what we will be doing with the help of this line graph, we will be connecting those two links, means link number 1 and 3 with the help of a simple straight line in this linear graph. So just like this, and to make it, because that is not actually they are physically directly connected, so we can just make this line a bit in a dashed pattern like this. So at this moment, as we can observe, this quadrilateral has been distributed into two triangles. So we can observe here or write that here I can insert the, for example, delta or triangular symbol here from here. So here for example, we can say that we will be using these two triangles that have been separated by the connection of this link number 1 and link number 3, this triangle 1 2 3, and same the triangle, for example 1 4 3, 1 4 3 or 1 3 4, that can be written in any order. So in these triangles we will be connecting. Now we will be using the Kennedy's rule that actually states that the here I can again show it statement. That any three bodies in plane motion will have exactly three instant centers, and they will lie on the same straight lines. So that actually means in this graph that, as we can observe here, that this instant center 1 and 2, we can first of all label these permanent instant centers on the diagram here. For example, I can just copy this label and we can just paste it here, and we can just type here that this is, because this is directly connecting link number 1 and link number 2, so we can orderly type it that link number 1 comma 2. So in this way permanent instant center have been so in this way just copy this label and paste it here. This is link number 1 and 4, and again just copy paste it here. Sorry, because this is connecting link number 3rd and link number 4, so orderly you can write it here. This is link number 3rd and this is link number 4, link number 3rd comma 4, and after that again just paste this label and just copy it here, and this is connecting point A is actually connecting link number 2 and link number 3rd, so this is link number 2 and this is link number 3rd orderly. So in this way I1 2, I2 3, I3 4 and I1 4 instant center have been located. So now we are required to locate the instant center 1 comma 3, means the instant center connecting the link number 1 and link number 3rd, because these two links are not directly attached. So as the Kennedy's rule actually states that any three bodies in plane motion will have exactly three instant centers and they will be lying on the same straight line. So that actually means that these two instant centers, for example instance number 1 comma 2 and instance center 1 and 4, so the third instant center, as we can observe here, this link number, for example if at this moment we are considering this triangle 1 2 3, this triangle is called the trio, means combination of three links. So link instant center 1 2 and instant center 2 and 3, for example. So the third instant center 1 comma 3 will be located on the extension of these two instant centers, instant center 1 comma 2 and center 2 3. So what we will be doing, that we will be using a simple straight line and we will be proceeding straight line that will be collinear with this line, which is actually connecting instant center 1 comma 2 and 1 comma 1 subscript 2 comma 3. So the third line, the third instant center, which is actually the common instant center for this the connection of for the combination of this link number third and link number 1, that will also be located on this line. So that line actually can be extended in this orientation or in this orientation, straight in any orientation. So like this. In this way. So that means the third instant center that will also be located on this line. So again we can make this line in the dashed pattern, because this is just a reference line here. For example, we can use any dashed pattern here, and again using the Kennedy's rule we can show here that from the line graph we will be using now other trio 1 4 3 triangle. So we can observe that link number 1 comma 4 and instant center 3 4 or 4 3, these two instant center, the third instant center, which is actually directly connecting link number 1 and link number third. So that instant center will be located on the extension of this, the extension of these two instant centers combination or connecting line. So in a similar manner, just we can, for example, copy this line and we can just paste it here, and then we can relocate it here, reorient it here like this. We just place it collinear like this. In this way, exactly collinear, overlapping the original linkage, which is actually connecting the instant center I1 comma 4 and I1 3 comma 4. So in this way that these lines can be extended so that the intersection is made like this. In this way. So as it can be observed that here the intersection has been made, and at this on the other side the intersection is not made. So we must do this practice, that we will always be extending these lines, which is actually connecting the permanent instant center in both orientations, in this orientation or in this orientation. So in the orientation in which the intersection is actually located, so that intersection will be the required instant center. So as we can observe here, the lines have been intersected here, so this is the required instant center. So just copy any label from here and just move it here and type it here 1 comma 3. So in this way the fifth instant center has been calculated To further highlight the intersection, we can just use simple shape figure and just we can draw a simple circular shape like this. So in this way, link number instance center I1 comma 3 unknown instance center has been calculated like this. So after that, the next third instance, the sixth instance center, which will actually be for the two bodies which are link number 2 and link number 4, which are not directly connected with each other. So what we can do, we can draw another trio. So for example, we can connect link number 2 and 4 like this. So we can use, for example, some different pattern for this dash pattern. For example, we can use like this. So in this way, now we will again be using the other triangles like this. Sorry, the diagram is actually moved. So here we can just we must be careful that the whole diagram may be moved, but if any single line or object is moved, then the diagram will be distorted. So we must be careful like this. As we can observe, the whole diagram is moved, so no issue. So the other trio, we can write it here, triangle 1 2 4 and 2 3 4 2 3 4. So in these two trios, we can in a similar manner observe that instance center 1 2 and instance center 1 comma 4. So the third instance center 4 2 will be located on the extension of the line which is actually connecting the instance center 1 comma 2 and instance center 1 comma 4. So as we can observe here, this is the instance center 1 comma 2 and the other instance center is 1 comma 4, that is here. So the line we can draw here, for example, like this. In both orientations, right or left, in this way, exactly overlapping the link are directly connecting. So again, the change the outline pattern, dashed pattern like this. And as we can observe that the third instance center 4 comma 2 will be located on the line connecting the instance center 1 comma 2 and 1 comma 4. Here this is 1 comma 2 and this is 1 comma 4. So in this way. So to make the intersection, we will be using the other trio, means the triangle 2 3 and 4. So in this triangle, we can observe that this is the instance center 1 subscript 2 comma 3 and this is 1 subscript 3 comma 4. So we will be for example, we can independently draw another line here like this, for example, exactly collinear, sorry, here like this, make it exactly collinear or overlapping, here like this, exactly collinear as possible, here like this. So again change its pattern like shape, format, for example, like this. So now just copy any label and paste it here. So in this manner, this is actually instant center 2, 4. So 2, 4, this sixth instant center has been located here, and further, for example, we can just copy this to locate here like this, or we can use down arrows, up and down arrow, to exactly locate here like this. So these two unknown instance centers have been located. Once these instance centers have been located, and after that the only requirement will be to calculate the angles. So angle single symbols using these arcs can only be a normal way. Those can also be copied and that can be pasted here at any location, then can be moved out here like this, sorry, here like this, and after that we can just move it like this, and just like this. In this way, so the angles using the help of arcs can be just shown here like this, just move it here like this, here like this. So these angles are actually to be calculated. So while working graphically, the angles at A and B and I1, 3 will be measured with the help of protractor. So in a similar manner, here like this. So now actually we will be solving this triangle triangle A I 1, 3 and B. Here, so the triangle A I 1, 3 and B. So in this triangle the angles will be measured, for example graphically, so that those angles can be measured here. For example, we can copy this protractor here and just we can paste it here at this location, and after that we can just move it here like this, and at this moment we can, for example, make the zero line, for example here in this way, and this origin of this protector exactly matching point B or this permanent center I1, 3, 4, and again using this rotation that must be exactly overlapping, zero line must be overlapping this line. So now the net angle that we can calculate here, that as we can observe, if we read the internal graduation or markings, as we can observe, this is 0 degree, 10, 20, 30, 40, and here as we can observe approximately here is one written 140. So here we can observe, for example, here it is 145, so less than 145, so here it is 144. So approximate angle, as we can observe here, written is 144. So in this way the angle has been graphically measured, so with the help of protractor. So practically, physically, while we'll be using pencil and scale method on the A4 size pages, so with the help of physical protractor the angle will be measured like this. So the angle has been calculated, so we can just copy any label from here for the mentioning of angle. So just copy and paste this label, and here we can relocate this, that call this the angle symbol that can also be inserted from here in the symbols. We can search it out here, that may be available. So that symbol can be found out, but that can simply be used using the less than symbol from keyboard. So the angle at, for example, we can say angle at B is 57 degrees. So sorry, this angle is actually as we have recently calculated, this angle is somewhat 144 degrees. So angle at B is 144 degrees. So again, in a similar manner, we will be moving this protractor here like this carefully, and its center will be placed here of this protractor, and after that, for example, we can just rotate with the help of this rotation symbol. So again, place the 0 degree line along one of the lines to be measured angle from. So in this manner, 0 degree line is on along link AB, and we are required to find the angle between the line I1 subscript 2 3 and I1 subscript 3. So the line connecting these two instant centers. So that angle can be calculated by observation. Here again, make it as correct as much as possible. So here now we can observe that the angle is actually the internal protractor graduation mark. So this is 10 degree, so here is 20 degree, but as we can observe, the line, this line is behind or before this 20 degree mark. So it is approximately, we can say, 10 degrees. So this is approximate graphical measurement by observation. So we can just copy paste this label again here at this location, or we can just here like this, and this is we can show it with the help of point A. For example, an angle at A means the angle at A is 19 degrees approximately. So or these angles can be analytically calculated as well. So once these angles at A and B have been calculated, the angle at the vertex I1, 3 can simply be calculated by subtracting the sum of these angles at A and B from 180 degrees. So the I can write it here that the angle at I, just copy paste it here carefully, 1, 3, that will be equal to 180 degrees minus the sum of angle the angle at B plus the angle at A, in this way. So as we can observe that will be equal to 180 minus angle at B is 144 and angle at A is 19 degree approximately. So the result here that can be that 180 degrees minus 144 minus 19. So here it comes 17 degrees approximately. So the third angle that can be labeled like this, just here the angle at I1, 3. Here the angle is 17 degrees in this way. So these angles have been measured with the help of protractor graphically. At this stage I will also be explaining that how to calculate these angles trigonometrically, means using the alternate or corresponding angle technique. So for this, wherever the angle measurement is required, we will always be using the imaginary horizontal and vertical references. So for example, just draw a horizontal reference line at this location here like this. Just make it exactly horizontal as much as possible by observation. Here like this. So its length doesn't matter. So as it can be observed here that the here the angle, this angle, as we can observe the cursor is at this locations, mean this angle is theta 41, the coupler angle 57 degrees. So the angle at this location that can be, for example, just copy this arc here. Here like this, that this angle that will be equal to 180 degree minus theta 41. So just copy this label from here. So this angle we can show here that this angle will be 180 minus theta 41, which will be equal to actually 180 minus 57. We can calculate it here, 123 degrees. So 123 degrees. So as we can observe, the angle between I1, 3 and I1, 34 line and between this line AB will be equal to the sum of this angle 180 degree minus theta 41, because this angle, and if we can sorry, we can, for example, just copy this arc and we can resize it just to show the corresponding angle here, like this. Means this internal, this angle and this angle are corresponding angles, or in Urdu we are familiar that these angles are called mutanazira zawi. So these are called corresponding angles. So these are equal. So, and this angle here between this horizontal and this line, that is equal to the alternate angle theta 31, which is 19 degrees. So that means we can just copy just for reference here, and we can just paste, sorry, yes, we are to copy paste this angle here, at like this. So this angle at theta 31 and this angle here, these are alternate angle. So the angle at B, total angle between line AB and I 3 4 and I 1 3 incident center are B 1 comma 3 incident center will be equal to the sum of angle of this angle 123 and plus 19. So as we can calculate from here that if we add in this angle 123 plus 19, so we can observe this is equal to 142. So analytically, as we can observe, the angle becomes 142 and our angle from direct measurement is angle 144. So there is a 2 degree variation or discrepancy, so that is allowable. So that means our angle is 100% correct, because our angle with the help of protractor is 144 degrees, but due to the sum of these angles which have been calculated, these corresponding or trigonometric technique, these are giving only a 2 degree difference, so that is allowable. So in this way, so in a similar manner here we can observe, I am just simply orally stating that this is theta 240 degrees. So the angle between this line and this horizontal line will be the same. This is called the corresponding angle. So here the corresponding angle total between this line and this horizontal line will be equal to 40 degrees. So between this line AB and this horizontal line is already available angle 19 degrees. So the angle between this line and this line AB, because we are required to solve determine all the angles in this triangle A I1 comma 3 and B in this triangle. So that angle will be 40 minus 19 degree, and as we can type it here, 40 minus 19 degree, this is will equal to 21 degrees. As we can observe here, 40 minus 19 degree, this is equal to somewhat 21 degrees. So as we can observe here, the angle graphically measured is 19 degrees, so there is again a 2-degree difference, so that is allowable. So that is actually the limitation of observation with the help of due to measuring with the help of protractor, so that is allowable. So our angle is are correct up to much extent. So actually the approach was just to show how the angles are measured. So in this way the angles have been calculated trigonometrically as well as graphically with the help of protractors. So in this way angles have been calculated. After that will be a requirement to calculate the length of these sides. So the length of these sides means length of uh, in this triangle angles have been calculated in triangle A I 1 comma 3 and B. So now we will be determining the side lengths, means we will be determining the length A I 1 3, and in a similar manner we will be determining the length BI3, and AB length is already known because that is actually the coupler or connecting rod. Already its length is given in the problem statement, which is equal to 120 millimeter. So these the length of these lines will be calculated using the law of sines trigonometrically. So I can just for your ease here, as we can observe, if we are in this way pressing enter, so the diagram is distorted. So I have done it undo. So these we can just type here instead of typing there, because the diagram was being distorted. So here we can type the law of sines law of sines. So the law of sines will be like that A 3 divided by sine of angle sine of angle, because A in front of the side A I 1 comma 3, the angle is the opposite angle is the angle at B. So we can type it here and like this here. So in this way law of sine, I'm just here, I'm not properly typing the equation with the help of equation editor, I'm just actually making you understand that how the law of sign will be applied. So in this way, all three terms can be written here. For example, just copy here and then paste it here. So here we can write it bi13 will be equal to this, and after that the last term will be, for example, ab. And here will be AB, and here the angle actually in BI13, the opposite angle is angle at A. So type it here, the angle at A, and here we will be typing the sign of the angle, because the opposite angle of side AB is I13. So just type it here, I13. So in this way, so in this way the law of sign will be applied. So by inputting the terms, the law of sign will be giving the value. If we will be making the calculation, we can observe that the values that I am mentioning here, you can calculate these values using the above formula yourself. So to shorten the video, I am just mentioning here the calculated values which I have myself calculated. So the values which I have calculated, AI1 comma 3 is 242, sorry, 242.66 millimeter approximately. So you can verify them. If you find any mistake, let me know. And BI13 that will be equal to 135.85 millimeter. So in this way, once as we can observe, this complete triangle of instant center have been calculated. So after that we will be determining the angular velocity of this link AB, which is in complex motion. So here at this stage I will be answering the question that was made by a student while in the class. Student question was that why we are using the instant center I1 comma 3 instead of instant center 1 comma 1 subscript 2 comma 4. So actually the reason at this stage here is that actually the instant center 2 comma 4 is not directly involving the link number third, which is in complex motion. So actually as we can also observe that link number third, which is actually in pure rotation about this instant center 1 comma 3. So as here it is mentioned that instant center I1 comma 3 is actually the instant center of the link number 1, which is the ground link, and link number third. So actually I1 comma 2 I subscript 2 comma 4 is not the instant center for link number third. It is actually the instant center of rotation for the link number 2 and 4. That is not actually the instant center for the link number third. And because these two links, link number 2 and link number 4 are actually in pure rotation, so they are not required to be solved. Actually the concept lying behind this instant center technique is actually we map the body or the link in complex motion to be in pure rotation. So actually practically as we observe that the links or the bodies in complex motion are neither in pure translation or neither in pure rotation. They are actually in simultaneous translation and rotations, or in the partial translation or partial rotation simultaneously. So in we actually in the instant center technique map the link in complex motion to be in pure rotation about the instant center at the moment considered. So actually this is the technique, means these are actually some two straight lines that have been drawn on an extended body which is actually have a fixed pivot located at I1 comma 3 at this instant center, and that disk is actually pivoted about this point, this instant center I1 comma 3. So due to this reason we will not be using the instant center 1 subscript 2 comma 4 because that is not the instant center of link number third, which is in complex motion. So actually we always be considering the link, we will always be considering that link which will be in complex motion, as the link number 2 and link number 4 are not in complex motion, they are in pure rotation and they cannot be directly solved out. So they because actually the input from the crank is transmitted with the help of this coupler link to the output link. If we are solving this input link and the output link with the help of this instant center 2 comma 4, so they are not directly attached, so the input from the crank cannot go directly to the output link, so there is no connection. So in this way actually we imaginarily we calculate the information or data for this point A, means the velocity of this point A with the with respect to this fixed instant center I1 comma 2 or O2 about which it is pivoted. and once the direction and magnitude of the velocity, absolute velocity of point A has been calculated, and because this point A is common to link number 2 and link number 3, after that we actually momentarily or imaginarily shift this point or relocate this point at the link in complex motion, which is link AB. So that point is actually moved or transferred or shifted to the link AB, and with the help of point A we actually calculate the data and information or the velocity, magnitude and direction of point B, which is again located on the complex motion link AB. And once the information or data for the point B has been calculated using the shifted or transferred point A, then we will be transmitting or transferring that point to the actual physical link, which is the coupler link. So maintaining the same orientation and magnitude, because that is the common point, that point will be shifted to the rocker point at point B, and after that, because the rocker is actually pivoted about point 0.04 and is in pure rotation about 0.04, so simply the magnitude of that velocity Vb will be divided out by the length of the rocker, which is actually denoted by the C, which is actually 80 millimeter from the data, and that will be giving the angular velocity of the rocker link. So in this way, so that was actually the reason we use the instant center I1, 3 instead of using the instant center 2, 4. So that answer has also been made. If you have still any question, you can ask. Now we can actually graphically measure the lengths of these sides. So with the help of, for example, some linear scale, just I have for example this scale here at the moment, so I can just copy this scale from here at this location and just for example paste it here, and again we can relocate like this. Here, or we can better send behind text, for example like this, so that the readings are correctly measured, error free. So as we can observe here, that as much as possible we can use up and down arrows very carefully like this for better placement here. So here as we can observe here particularly from this here as we can observe here is 11 centimeter, 11.5 and 11.6, 11.7, 11.8 or 11.9. so 11.9 centimeter according to this scale. And here from above we can observe the scale that 20 millimeter is equal to 1 centimeter. So our observation according to this graphical scale is actually 11 point, for example 11 point, we can say 11.8. so here we will be, sorry, you can type it here that these are actually the trigonometric values, and now I can write it here, the graphical values with the help of that protector that have been measured. As we can observe that the according to scale the length is 11.8, and we will be multiplying it with this 20, because 20 millimeter is equal to 1 centimeter. So as we can calculate here that 11.8 multiplied by this 20 centimeter. So as we can observe that the here it says that 20 to 36 millimeter. So our trigonometric analyticals are 242, so they are quite near. So these minute variations are possible or allowable. So our answer, our calculations are 100% correct and okay. So in this way graphical results are 236 millimeter of the length a I1, 3, and the analytical or geometrical results are 242.66. and in a similar manner we can now calculate the length b I3, and we can also verify, because as we can observe there were 2-degree measurement variation as well due to the limitations of the graphical technique, because the trigonometric or analytical technique give 100% results. So there are limitations in the graphical measurement in observation. So here we can observe that here approximately, sorry, here we can observe here that that is actually approximately 6.4 for example. So we can type here 6.4 multiplied by 20 according to scale. So this will be giving, we can calculate 6.4 multiplied by 20, which will be giving 128. So as we can observe here this is 135. So our dimensions or measurements are quite near. So in this way, graphically in this way measurements will be made. So actual my approach is just to make you understand how physically you will be measuring these values. So once these lengths have been calculated graphically and trigonometrically, so now we will be approaching that we will be determining omega 3. So for example we can just type here omega subscript 3 here like this, and sorry 1,3 that will be. And as we can observe here that, and now I just move this scale out, and as we can observe that now point A is actually in pure rotation, our link AB is in complete and pure rotation about I1, 3. So that means the center of rotation is here, and so, as we can observe that in the problem statement that the angular velocity actually omega, that was given in example sorry 323 page. Here, as we had observed that the angular velocity was counterclockwise, so that means the angular velocity vector here, the angular velocity vector the absolute velocity vector va was in this direction, because this is the this is actually moving the crank in the anti-clockwise or counterclockwise direction. So that means that this is actually the velocity v subscript a. So just copy any label and just paste it here. Here just change v subscript a here like this. So as we can observe that this va is actually now at point b, because that is actually common to both the bodies. So that is actually also perpendicular to the line connecting a I1, 3. So it is making actually the rotation in this direction, which we can show, for example, with the help of for example just arrow curve, for example, here like this, here like this, that the rotation will be in this direction. Sorry, here means the direction of rotation is actually clockwise like this. So this is just to make you realize that the direction of rotation of the complex motion link will be clockwise. So due to that reason, in the solution as we can observe here, that the omega 3 that has been calculated here is minus 4.12. so minus denotes the direction is clockwise, so as it has been shown here. So omega 3 will be equal to v subscript a and that will be divided by the length ai 1, 3, and that will be equal to, and as we can observe that VA is practically equal to, with the help of this crank about pivot O2, that was actually R omega and R was actually O subscript 2 and A and multiplied by omega 2, for example, omega 2, that was the angular velocity. So O to A, that was 40 millimeter multiplied by 25 and so this came out to be 1000 millimeter per second. So omega 3 so in this way. So now just divide it by AI 1000 divided by AI 13. So AI 13 graphically it is equal to 236. So as we can observe with the help of calculator that 1000 divided by 236, so this came out to be 4.237. so graphically the result is 237 radian per second. So as we can observe here, the answer that the author has written 4.121. so these are the analytical results. 4.121 radian clockwise, and our result is 4.237. so there is minute difference, so no issue, our results are 100% correct. And once omega 3 has been calculated, after that we will actually be determining the magnitude and direction of the velocity VB. So the direction of the velocity VB, that can simply be, for example, just copy pasted here, just say for example here like this, that this velocity actually of point B, that will be perpendicular to the line BI1, 3. So make it exactly perpendicular as far as possible. You can use with the help of protractor or just by observation. So this line, this velocity is actually VB, and its orientation will be such that it will not be violating the rotation of the complex motion link. So as the velocity VA orientation was in this orientation, and this was actually moving the complex motion link AB in the clockwise orientation in this plane, so the point B will also be moving the same link AB in the clockwise orientation. So the direction is satisfied like this. So this is the velocity of point B. Just copy this label at this location here. For example, this is actually V subscript B. So next requirement will be to determining the velocity magnitude and magnitude of the velocity VB. So as the angular velocity has been calculated, so the magnitude of the velocity VB, that will be equal to the magnitude of the velocity that will be equal to omega 3 multiplied by the length b I comma 3. So as we can observe that that will be equal to, that can be calculated here, that as we can observe that omega 3 in our case came out to be 4.37 radian multiplied by bi1 comma 3, and our graphical results show that is equal to 128. So here the result that can be calculated here, 4.37 multiplied by 128. So here the answer is 542.37. so as we can observe here, the answer is actually 542.37 millimeter per second. So this is the velocity of VB. So graphically from the book we can also observe that the magnitude that the author has calculated, this is VB, this is the VB magnitude, which is equal to 559.84 millimeter per second, and our graphical result is 542, so which is quite near. So no issue, the method is 100% correct. Graphical results always have some limitations of observation. So in this way VB has been calculated. So as I had already stated that once point B has been calculated on with the help of this complex motion link and using instant standard technique, after that we will be shifting to this common point to rocker pivot, and then that point will be actually rotated about 0.04, because actually that is physically practically the part of this rocker link, and rocker is actually in pure rotation or oscillation about 0.04. so now the omega 4, so omega 4 will be equal to, just copy this line here, so, and just modify it here. So this will be omega 4, so that will be equal to VB. So just here the VB equal to B, here VB will be divided by O subscript 4 up to A. So as we can observe that VB magnitude is calculated on above, say that is 542.37. so and BI3 is equal to 542.37 divided by BI3, that will be divided by 04A, and O for A means that is actually the rocker length, which is equal to 80 millimeter. And when this result was divided out by 80 millimeter, so this came out to be 6.779. so that means just type it here, that will be equal to 6.779 radian per second. And here we can observe the omega for a 6.998. so our results are 100% correct and near. So this is the method, and after that we can calculate the angles of these velocities with the horizontal in a quite simpler way, that are quite obvious and easier, so you can calculate them. So in order to avoid making the video lengthen or of larger size, so I will be closing or finishing the video session. And thank you all of you, and if you have any question you can fairly positively comment, or you can personally meet and ask. Jazakallah and Assalamu alaikum. God bless you.